Okay, so Unit 9, Worksheet 1, Qualitative Impulse Momentum. What I'd recommend we do for every single problem on this worksheet is to first read the question and then draw a picture that goes along with it, trying to represent what's occurring in the problem. So for problem 1, if you throw a ball horizontally while standing on roller skates, you roll backwards. Will you roll backwards if you go through the motions of throwing the ball, but hold onto it instead? Explain your reasoning. So, what we're told is that if you are standing on roller skates and you throw a ball, you roll backwards. So I'm going to draw what that is visually going to look like. So right here, this is going to be our initial condition, holding onto the ball. Then after that, I'm going to be showing the person throwing the ball. We are told in this scenario that when the ball travels in one direction, the person is going to travel in the other. For my initial condition, neither the ball nor the person is moving, so I'm representing my velocity vectors as just dots with no lines attached. At my final condition, the ball is moving one way and the person the other. One thing that we know from this unit so far is that there is a conservation of momentum. So if we're going from our initial to our final conditions, the total amount of momentum inside the system should be the same. So the momentum initial is equal to the momentum final. Well, for both of these, I have the mass of the ball and the velocity of the ball, plus our mass of the person times the velocity of the person. Those are all of the individual momentums that we have at the very beginning. That is going to be equal to the momentum of the ball times the velocity of the ball at the end, plus the momentum of the person times the velocity of the person at the end. We know that both the ball and the person have a velocity of 0. So it doesn't really matter what their masses were, because any number times 0 is going to give us 0. So overall, our total momentum before is going to be 0. That means all of the momentum afterwards have to add up to 0. We still don't know what the mass of the ball or the mass of the person is, but we know that the ball is traveling to the left, the negative direction, and that means that the person should be traveling right, the positive direction. So if we have a negative number and a positive number that get added together, that is possible to add up to 0. So overall, that initial situation that is provided for us makes sense. However, this problem is asking us, will you roll backwards if you go through the motions of throwing the ball, but hold onto it instead? So I'm going to actually be drawing that initial setup. Initial and final. Well, I'm probably going to have that same initial setup, a person holding onto the ball, and neither them nor the ball are moving. In the final condition, we're trying to figure out if that person, when they're still holding onto the ball, would they end up moving? We know that because they are holding onto it, that means that their velocity, or the velocity of the ball, will have to be 0. But we don't necessarily know what the velocity of the person is going to be just yet. That's what we'll be looking for. So I'm going to start this off the same way, where I'm going to be saying my momentum before should be equal to my momentum after. And I'm going to make the assumption that nothing really has changed since I did this all over here. So I'm still going to have my final momentum be equal to 0. And then we can just see left for the actual work that we got here. Now, for the final momentums, the momentum of the ball is the mass of the ball times the velocity of the ball, plus the mass of the person times the velocity of the person. We know that the ball, if they're holding onto it, has that velocity of 0 meters per second. And we know that, well, the person still has a mass, and we're looking for their velocity. Well, any number times 0 is 0, plus our momentum of the person. Well, overall, 0 plus any product, in order to equal 0, means one of these two terms has to equal 0. We know that this has to be some number greater than 0 kilograms. So therefore, this, the velocity, has to equal 0 meters per second in order for us to conserve our momentum. So overall, the person should not have any velocity. So to answer that question, will you roll backwards if you go through the motions of throwing the ball but hold onto it instead? The answer is no. You will not roll backwards. And the explain your reasoning is really just the work that we were showing. To summarize what we did, we started off by drawing a diagram representing the scenario. We identified the variables that we knew, such as the, well, relative masses of the ball and the person, and the velocities and directions. From that, we used our understanding that momentum is a conserved quantity, which is why we have the same amount of momentum before and after in order for us to say this is going to be equivalent. And then from that, we were able to plug in our values to calculate the individual momentums of each ball and person at the initial and final condition in order to ultimately decide that the person should not be moving if the ball itself ends up not moving.